अस्सलाम वालेकुम। सो आपको आ रही है स्क्रीन मेरी नज़र?
Yes, sir.
अच्छा, सो लेट्स बिगिन आवर today's lecture. ये मिनहाल स्वाति कौन है? ये डायरेक्टली क्यों नहीं आ सकता? ये इसी के बैच में है मिनहाल?
Yes, sir.
नहीं
Class
तो
में
ये
sir.
क्यों ये मुझे क्यों रिक्वेस्ट आ रहा है कि इस पे मैं एक्सेप्ट कर दूं? आउटसाइड है ना ये? ठीक है,
पता नहीं
उसको
सर.
अगर कोई उसका है तो ये प्राइवेट ईमेल में एक्सेप्ट नहीं करता। ठीक है, तो बता दे, अगर उसको कोई दोस्त है तो बता दे उसको कि ऑफिशियल ईमेल ही अलाउड है यहाँ पे। ठीक हो गया। Okay, let's begin the lecture. And this is about motion. So remember, we have so far um, covered statics. And now we are into dynamics, this part of the course. And in dynamics, we will have two sub-disciplines, kinematics and kinetics. So if you can, someone can recall what is the difference between these two. In kinematics, you study motion, and in kinetics you also study motion. The difference is here you study motion without being concerned about forces. Concern important है, इसका मतलब ये नहीं कि motion बगैर force के हो जाता है. There are types of motion or change in motion which require forces, but you are not concerned with that. And in kinetics you are concerned with forces as well. Forces causing motion and motion causing forces both. ठीक है, the interplay between forces and motion. So how do you quantify motion? So you will see motion as a change in the position of an object with time. Now for simplicity, in this part of the course we are concerned only with particle. Okay, so particle is the simplest rigid body. We're not interested in other details like shape, size, things like that. Of course, rigid body. So let's say you have a particle and you have some reference from which you make measurements, directions, and let's say the motion is along a curve. It can be any path. Okay, so at any point t, the position will be mathematically described by a vector from the reference to an arbitrary point. This point can be anywhere. So depending on the time, you can be here, here, here. So this is just a general time. Now here we represent that position, r equals. Now this is important because we want to distinguish between the magnitude r. So I can just say r of t to make sure that it can change with time. The magnitude can change with time, and the direction can also change with time. So usually you will see this notation, yeah. But here for simplicity, and I mean to avoid some clashes, we will use this notation. So E, this bold E, and I can say vector. Of course, it's a function of time because the direction can also change with time. And the subscript is R, which reminds me that this is a unit vector for R. Okay, R के लिए unit vector मैं लिख रहा हूँ. So if I want to represent this in the diagram, from here to here, this is the vector, and maybe, okay, along this direction, I have a unit vector, which I write ER, yeah, with an arrow. And when I have it in bold, then I don't need the arrow. Okay. Okay. Displacement. Now, so position, we discussed position now. Okay. Now we know what we mean by position. But motion is not position. Motion is change in position. Now we need a quantification or a mathematical description of the change. Now that change in position is what we mean by displacement. So delta R. Okay. So you have R of t, let's say at this time, and after some time, so you have, let's say you are here at time t, and after some time you are here, the new position vector is R of t plus delta t, and this difference is what you mean by the displacement. Now this is good for definition, but this is not very useful. The complication with this way of introducing displacement is that there is a lot going on between point P and point, let's say you have point P here and point Q here. Delta R will be this vector, this straight line, this vector in the straight line. Yeah? Now, the actual curve is this one. Yeah. So while this delta R does represent the displacement, so if I now want to ask you what is the magnitude of this, इसका magnitude कितना होगा? कोई बता सकता है? Will it be this length or will it be the length of this line segment PQ?
So is highlighted.
क्योंकि ये displacement में ये है. Now, is this what you want? If you want to know the distance, is this good enough? So it is not useful for us. Okay, not useful. What if we want to know this distance? Yeah, so this delta R is a problem for us. Okay, it is a good definition, but we need more. So we need to calculate this distance, and for that I would like to just summarize all these small distances, and that brings me to the concept of velocity. Velocity is a good concept because it tells me what happens at a point rather than what happens between points, because there is too much detail and I cannot deal with that. But a velocity is a simple thing. Yeah, it tells me what happens at this p. Yeah, so that's why I shrink these 2 points, and okay, you have this concept from calculus, tangent, and you just take the derivative of the position with respect to time. So all this differentiation is happening at the same point in time. Yeah, so with this R, okay, you can have your R dot of t, the vector. Now, just like I broke down the position vector into its magnitude and the unit vector, and remember this is a multiplication, okay? So I can do the same for velocity. I will have the magnitude of velocity and I will have a unit vector. I use the same notation E and the subscript V. Now this V is the speed. That is what we mean by the speed, okay? Speed is the magnitude of velocity. And because it's a scalar, you can always think of this as the derivative of some other scalar, and that, you know, is the distance, okay? So distance is simply the integral of the speed, okay? These are all scalars. So if I know the velocity and then I know the speed, I can now integrate that function from P to Q and I'll get my distance, okay? So that's why velocity is more useful than displacement, because it allows you to calculate distances as well. Now let's get back to this definition, and I will now switch the screen to another page. And because I cannot say bold, so I will use arrows here. So I have a vector R of t, and I want to differentiate this with respect to time, and this will give me velocity, the velocity vector. Now I need to do something. This R, I want to rewrite this as the magnitude, of course a function of time, and the unit vector. Yeah, so I just break down, this represents the magnitude, the speed is and this represents the unit vector or direction. This represents the direction. So if I now differentiate this, can you help me apply the product rule of differentiation? So what should I write here? Because I have two functions and I multiply and I want to take the derivative. So first will be, I can start with differentiating r, so it will be r dot of t times the unit vector, and the second is that I don't differentiate r and I differentiate the unit vector only. Okay, I have two terms and we now need to give meaning to this. Can you tell me what is the meaning of this term? It is which component of velocity? Now for that you need to think about, let's say, what if this was not there, or I would say if this was 0. Yeah. So when will this be 0? When one of these two is 0. Yeah? So if r is 0, then you don't have any curve. You don't move at all. But if r is not 0, then okay, this can be 0 because this is 0. Now when this is 0, what does it mean? That my vector, my unit vector, yeah. Remember, this was the origin, this was the point, and let's say this is r of t, yeah, and the unit vector along the same direction is er of t. And now I differentiate this unit vector. So I want, because unit vector will remain unit vector, the magnitude cannot change. So all it can do is to change the direction. These are possible new directions. Yeah, it is not supposed. So now the derivative of this unit vector with respect to time, if this is 0, it means that it cannot rotate, and there is no circular motion, no rotation, no rotation is possible. So when no rotation is possible, this terms must mean linear motion in a straight line. So it's actually, you can now call it the linear velocity. ये बात समझ आ गई? Now you can confirm that it is a linear velocity because the unit vector has not changed, only the magnitude is changing, and that is exactly what happens when you move across in a straight line. If you move in a straight line, nothing happens to that unit vector, it stays the same. Yeah, only the magnitude is changing. Yeah. So we can now flip the argument and say, okay, what if this was 0? What if this is 0? Now then this term will represent what? This will be pure rotation. Okay, no motion along the straight line because you must be in a circle, because it means that this is you're not differentiating r. So if you are in a circle, the magnitude doesn't change, only the unit vector will change. And when I say the unit vector will change, I only mean the direction. Okay. So, but there is one problem. There's one problem which we need to solve. Has everybody understood this decomposition into two components? Yeah, this is the linear velocity, and this is the, I will not call it angular velocity because it is still a component of v. This is the component of, I will say circular. Okay, circular.
सर लेफ्ट वाला जीरो इसलिए बिकॉज सर्किल में जो यूनिट वेक्टर टोटल सम उसका जीरो होगा,
बिल्कुल
राइट?
नहीं, लेफ्ट वाला सर्कल में
यस सर। लेफ्ट वाला जीरो क्यों हुआ?
लेफ्ट वाला जीरो क्यों है? क्योंकि आर चेंज नहीं हो रहा ना, आर इज कांस्टेंट,
सही से, ठीक है।
so r is the magnitude, yeah. So although I am writing of t, but if r dot of t is 0, then r cannot depend on time, okay? It has to be constant. And when r is constant, it has to be a motion in a circle. So basically, this velocity is a velocity, yeah, which changes direction, and that's why I can call it tangential velocity. You must have heard this name. Or maybe you can call this the radial velocity, radial because it's along the radius, yeah? And you can call this the cross radius, cross radial. You can give it any other name, but one thing is clear, that it is not a velocity in a straight line, okay? Now one thing is disturbing in this expression, and that is, here this is a unit vector, yeah, and this was also a unit vector, so it's the same unit vector. Now the advantage of having a unit vector is that you can give meaning to this. This will be the magnitude, yeah, and here because it's unit vector, so you can say this is the magnitude. This is the magnitude of this component. But can you say something like that here? Can you say this is the magnitude? Is this a unit vector? Can somebody think and tell me? Remember, you differentiate a unit vector with respect to time. Let's consider this, okay? I differentiate a unit vector with respect to time. So it will be a change in the unit vector, yeah? Remember, I have a unit vector like this, and another unit vector after time t like this, and this will be a change, delta E. One thing is clear, that because ER is a unit vector, this must be not just any circle, but the unit circle. समझ आ रही बात? Why this circle must be unit circle? ये बात समझ आ रही है?
नहीं सर।
क्योंकि ER is a unit vector, yeah, along the radial direction. So you cannot have a magnitude larger than 1 or less than 1. So it has to be the unit circle. Okay? अब यहाँ पे क्या है? So let me take small change delta ER, and then I take small change in time, and then I take the limit. Now this delta t is small, this is small. Can you tell me anything about the magnitude of these two? Of course, this is a vector and this is a scalar. Time is scalar. But if you ignore that and you only take the magnitude, let's say the magnitude of this, yeah, the magnitude of this and the magnitude of this, are these two magnitudes the same or not? Tell me. Why these two magnitudes will not be the same? क्योंकि डेल्टा टी तो कोई भी वैल्यू हो सकती है ना उसकी, ठीक है, स्मॉल है, लेकिन एनीथिंग स्मॉलर देन एनीथिंग व्हिच इज नॉट जीरो, लेकिन ये तो, इसके बारे में क्या ख्याल है?
No idea sir.
Okay, so that actually brings me to the angle. आपके पास एक सर्कल है जो किसी भी रेडियस का हो, तो उसमें ये जो डिस्टेंस है ये it depends on the angle as well as on the radius, yeah?
Yes, sir.
But what if this r is 1? And if this is radians, then this distance will be equal to what? The angle, yeah?
Yes, sir.
So which means that if we are on a unit circle, yeah, then the change in angle and the change or the length along the unit circle, it will be magnitude, the magnitude will be the same. So now what we can do is that we cannot simplify this, yeah, but we can do something else. We can apply chain rule here. So instead of differentiating with respect to time, I differentiate with respect to the angle in radians. Theta is in radians, yeah. Because that simplicity is not in degrees only, it's only in radians. And now I differentiate angle with respect to time. आपको याद है कि ये क्या चीज है? ये d theta over t.
Angular velocity, sir.
Yeah, angular speed. ये वेक्टर नहीं है ना. Angular speed. Now you think about this vector, this derivative. अब वो क्वेश्चन इसके बारे में दोबारा पूछ लो. Think about this dr, der, yeah, the magnitude, and this d theta, the numerator and the denominator. And let's say I only consider the magnitude so that I don't worry about the vector thing. Will these two magnitudes be the same now?
Sir, differently होंगे, same नहीं होंगे.
No, they must be the same. Why? Because they are now on the unit circle. हमें पता है यूनिट सर्कल में यहाँ जो चेंज है वो वही चेंज एंगल भी होता है. समझ आ गई? ER is a unit vector which is rotating in a unit circle.
Yes, sir.
जो इसने दो पॉइंट्स के दरमियान डिस्टेंस यहाँ पे कवर करना है वही डिस्टेंस, it has to be numerically equal to the angle. So now we can say that although this was not a unit vector, yeah, but if we apply the chain rule and if we separate that omega as a factor, what we have after that is a unit vector. समझ आ रही बात? So the summary is this, that the unit vector differentiated with respect to t is omega times the unit vector differentiated with respect to theta, and this new thing is a unit vector in its own right. And we know it is a unit vector which moves along a circle. अब पता है move along a circle के लिए हम theta को as a reminder use कर सकते हैं. So we can say that this unit vector is moving in a circle. Yeah, unit vector, time dependent unit vector. Is this clear now?
Yes, sir.
So we can now, and one more thing, before I actually move to the next slide. जब मैं circle की बात कर रहा था, and this is at any point R is away from the circle, away from the center, yeah? Now, when you differentiate this E R with respect to theta, I want to know where is this new vector. So I have two vectors. I have ER, which points along R, Now I want to know this thing, E theta, which is d er over d theta, points along what? Of course, it points along theta, but I need to know what are these two directions, or what is the angle between these two vectors? Can you guess? If I want to know the angle between this vector and this new vector. For that, let's think about this. Remember, we started with ER, and let's think of it as a function of theta, not as a function of time, because we are differentiating with respect to theta. So see it as a function of theta. Now, because it is unit vector, what is the magnitude? Tell me. Magnitude is 1, yeah? Agreed? And what if I write this thing? Can I do that? What will be the dot product of these two? This will also be 1, yeah? The dot product is simply the magnitude squared. Now I want you to differentiate both sides with respect to theta. Differentiate. So differentiate 1. Right side पे मुझे क्या मिलेगा? बताएं. 0 है. और left side पे I can again apply the product rule. So without differentiating ER, I can differentiate the second one with respect to theta, and I can do the same again. So it's basically twice of this. Now I have 2 times the dot product equal to 0. What this means is that these two vectors, yeah, the vector itself and its derivative with respect to theta, they are what? इनके दरमियान कौन सा एंगल है? बताएं. They are perpendicular. Right? Okay, only when two vectors are perpendicular, the dot product is 0. समझ आ गई ये बात?
Yes, sir.
And this will be true for any unit vector, because unit vector, if you differentiate it in such a way that you get another unit vector, ठीक है ना? So अब यहाँ पे खैर एक चीज है, अगर ये हम विद रिस्पेक्ट टू थीटा ना भी करते ना, तो इसने फिर भी 0 आ जाना था. क्यों? क्योंकि इसका सिर्फ मैग्नीट्यूड डिफरेंट होता ना, या यहाँ पे इस डेरिवेशन में अगर ये यूनिट वेक्टर ना होता, नहीं ये तो यूनिट वेक्टर है, सॉरी, ठीक है. अगर ये कांस्टेंट होता, कांस्टेंट, you had a vector, a constant vector which is not a unit vector, तो ये कांस्टेंट होता, ये भी कांस्टेंट होता, ये भी कांस्टेंट, and this would still have been 0, ठीक है ना? So it's the differentiation with respect to theta that is the key. So now we can.
Sir, हम different book पे आ गए.
ये वाला टॉपिक है, ये हम डिफरेंट बुक से कर रहे हैं, क्योंकि उसमें एक और बुक है, उससे हम एग्जांपल करेंगे, लेकिन उसमें डेफिनेशन बड़ी बेसिक्स है ना. So I just want you to have a clear picture of this vector differentiation, okay? Differentiation of it. So you differentiate the displacement, then you get velocity, and that velocity. Now I'm just repeating myself because I already did that in the other page. If I'm only differentiating the magnitude, it means that I'm in a straight line, so that gives me linear motion. Yeah, subscript is r, and if I'm in circular motion, then I don't differentiate the magnitude, I only differentiate the unit vector. Yeah, this one. And but because that is not the derivative is not a unit vector, I do some trick chain rule, and I get a unit vector, which is the derivative of er with respect to theta, and theta dot is the angular speed, and that is actually that gives me the velocity, tangential velocity along a circle. ये यहाँ पे आपको नजर आ रही है ना, ये वाली, ये this is what I'm talking about. ये v theta यहाँ पे ये है basically आपकी, ये ठीक है. और अगर सर्कुलर ना होता तो ये VR होता. Basically, in this curve, you have both of them present. In this motion, only V theta is present, and if you were in a straight line, only VR will be present. In general, both components will be present. Okay. Now you also know the speed, which is the derivative of distance. Distance is the integral of speed. Yeah. And we can now do another trick here. Watch carefully, okay? I will start from this. Yeah. So I know that this velocity is the magnitude times the unit vector. I'll not change the unit vector. Yeah. But the magnitude I know is s dot. Yeah. S dot times the unit vector. Velocity is s dot times the unit vector. If I start with this definition again, and instead of differentiating r with respect to t, I apply the chain rule. This time I differentiate with respect to s first, distance. Remember, distance can be along any curve. And now I differentiate s with respect to t. Can you tell me what is ds over dt? This is s dot, yeah?
Velocity.
Speed, yeah, speed. S dot.
Speed.
So it's s dot. So I can even ask you to focus on this formula, and here I know that this s dot is v, yeah? So I can say it is v times dr over ds. Can you now combine these two and tell me what you can learn from this? V is the same, yeah? And they are both definitions of V. So what you learn from this is that this EV is actually the derivative of R with respect to the distance. समझ आ गई बात? Is this clear now?
Yes, sir.
And even if you, let's imagine that you came late and you did not follow this derivation, and I ask you to justify this without this derivation. Even that is possible. ठीक है? अभी जिस तरह पहले हमने कहा था कि when we are in a unit circle, yeah, so the change here and the angle will be the same. Now here we can imagine a circle that is not necessarily a unit circle. Yeah. Resume. So now you imagine any circle of any radius. Now along any circle dr, remember r is this vector, yeah, from center to any point. Now dr will be some short distance along that circle, yeah, but that is also what you mean by ds, yeah. So ds and dr, they will have the same magnitudes. ये बात समझ आ रही है? This time we don't have theta, we have ds. Ds, you know, is this distance. So ds and dr, if these p and q, let's say they are very short, they're very close to one another, then you will have the same magnitude, and this will be another unit vector. Okay. So now we move on to acceleration. अब acceleration हमें इसलिए चाहिए, इसमें कोई क्वेश्चन है अभी तक, या before I move on to the next topic?
जी सर, एक क्वेश्चन है सर, ये आपने रेडियंस वाली चीज जो बताई थी, रेडियंस चेंज हो रहे हैं एट द सेम रेट एज आपका वो ई जो चेंज हो रहा है, वो एक्सप्लेन कर देंगे फिर सर?
नहीं, ये तो यूनिट सर्कल, यू हैव अ यूनिट सर्कल, या तो यूनिट सर्कल में हाउ वी डिफाइन द रेडियन एंगल, हम डिग्रीज इसलिए यूज नहीं करते कि हमें ये चाहिए कि रिमेंबर यू हैव अ यूनिट सर्कल में जो भी वेक्टर होता है यहाँ से, उसको आप यूनिट वेक्टर कह सकते हैं या नहीं कह सकते? All these are unit vectors, yeah?
जी सर.
So now you imagine the motion along unit circle as if it were a motion by a unit vector. वो unit vector move कर रहा है basically. सही है?
Yes, yes.
अब जो DER है, वो उस unit vector का distance है किसी भी दो points के दरम्यान, if they are close by. D का मतलब they must be close, yeah? ठीक है?
So distance क्या है?
Distance between any two points as this vector is moving.
So DER?
DER, no, ER is the unit vector, this unit vector. This is the unit vector. मैं इसको R इसलिए नहीं कर रहा कि R का length तो 1 नहीं होता ना. ER is the unit vector along radius. ठीक है? So I am moving in a circle of unit radius. तो ये जो यहाँ पे मैं normally R लिखता हूँ, अब मैं क्या लिख सकता हूँ? ER, because it's a unit vector. Now this ER changes its position. Now this ER is here. Now this is what I mean by DER. Okay, this length. Actually not the length but the vector. Yeah. So that will be equal to the angle. Because it's unit circle. Unit circle में ये होता है ना कि जो arc length होता है, it's equal to the angle. And that is why I say that these two will have the same magnitude, and that's why this derivative will be a unit vector in its own right. ठीक है? And not only that, we also discovered that differentiation with respect to theta gave you a vector that was perpendicular to whatever you were differentiating. You differentiated which vector? You differentiated ER, yeah? And the derivative, which is E theta, they must be perpendicular. So what we learn from this is that E theta and ER, they must be perpendicular. Because we showed that differentiation with respect to theta gives you a rotation of 90 degrees, okay? वैसे this rotation of 90 degrees as a result of differentiation, this should also remind you something in phasors, yeah? वहाँ पे भी j omega आपको याद है ना, j जो आता है, j is a rotation. Can you recall that? वो इसी से related है. ठीक है? So whenever we differentiate something which is along a circle, that will give you a rotation. Okay, now let me give you another food for thought. So far in this lecture, we discovered two things. Actually, we discussed two things. We discussed displacement. The displacement is not r but delta r, yeah? ठीक है? A change of position. And we discussed velocity, which is derivative. Velocity is the derivative of displacement. Derivative of displacement. Actually, it's the derivative of position, to be very honest. Yeah, it's the derivative of position vector. अब आप मुझे ये बता सकते हैं कि इन दोनों में अगर मैं पूछ लूं कि एक तरफ वेलोसिटी है, दूसरी तरफ क्या है, पोजीशन है या डिस्प्लेसमेंट है, तो डिस्प्लेसमेंट और वेलोसिटी में कौन सा कॉज है और कौन सा इफेक्ट है? What causes what? Can we say that velocity is an effect? Displacement क्या है?
Cause है.
और velocity effect है.
Effect है.
अच्छा, तो आप ये कहना चाहते हैं कि displacement is the cause of velocity, yeah? अगर if this arrow represents cause effect, yeah?
Yes, yes.
अब इसमें cause effect में ये जरूरी है ना कि अगर ये ना हो, let's say there is no displacement, so then there should be no velocity, yes?
Yes, yes.
So when you hit let's say you have a hockey stick and you hit a ball, या बैट के साथ आप बॉल करते हैं, तो उस टाइम उसकी इनिशियल वेलोसिटी क्या होती है? नॉन जीरो होती है ना?
जीरो होती है सर.
नहीं, इनिशियल वेलोसिटी जीरो होती है. इनिशियल वेलोसिटी उसकी जीरो होती है. तो वो चेंज
जब हिट करने से पहले पॉइंट जीरो होती है, जब हिट होता है तब मैक्सिमम होती है.
हाँ, तो वो मैक्सिमम हो जाती है ना. मैं लेट से वी आई प्लस में कहता हूँ, वी आई माइनस नहीं कहता, ठीक है ना? प्लस का मतलब है कि जस्ट आफ्टर. तो उस टाइम पे डिस्प्लेसमेंट कितनी है?
जीरो.
तो इसका मतलब है कि वेलोसिटी डज नॉट रिक्वायर डिस्प्लेसमेंट.
सही.
ठीक है. अब आप एक और बात कर लें. लेट्स से देयर इज नो वेलोसिटी. कैन यू इमेजिन डिस्प्लेसमेंट विदाउट वेलोसिटी? लेट्स से आपने सुबह देखा कि देयर वाज समथिंग, लेट्स से अ कार वाज स्टैंडिंग हियर, और आपने शाम को देख लिया कि वो कार इधर आ गया है, ठीक है? तो पोजीशन चेंज होगी ना, डिस्प्लेस हो गया ही. यस.
Yes.
Now do you want to tell me that this happened because there was no velocity involved? ये खुद ब खुद हो गया, there was no velocity was at play.
सर लेकिन वेलोसिटी के लिए भी डिस्प्लेसमेंट जरूरी नहीं होती.
नहीं, मसला ये उल्टा बता रहे हैं ना.
वेलोसिटी दोनों एक दूसरे के ऊपर डिपेंडेंट नहीं है.
नहीं है ना, नहीं है, मैंने बता दिया ना. वेलोसिटी के लिए डिस्प्लेसमेंट जरूरी नहीं है.
सही.
समझ आ गई? डिस्प्लेसमेंट के लिए वेलोसिटी जरूरी होती है. डिस्प्लेसमेंट असल में आती वेलोसिटी की वजह से. जो आप डिफरेंशिएशन कर रहे होते हैं ना, डी आर ओवर डी टी, तो ये तो आप सिर्फ कैलकुलेशन कर रहे हैं. दिस इज अ कैलकुलेशन, दिस इज नॉट ए कॉज इफेक्ट रिलेशनशिप. समझ आ रही बात?
सही.
आप वेलोसिटी कैलकुलेट कर रहे हैं कि चूंकि इतना चेंज मैंने पोजीशन में ले आया हूं, तो वेलोसिटी मेरी इतनी हो गई, ठीक है? ये ऐसा ही है कि किसी भिखारी को आप पैसे दे रहे हैं, ठीक है ना, और फिर आप देख रहे हैं कि इसको महीने में मैं कितने पैसे देता हूँ. उसका मतलब ये तो नहीं है कि वो पैसे भिखारी खुद जो है ना वो जनरेट कर रहा है, वो आप ही दे रहे हैं ना. सो ही इज नॉट गिविंग यू द मनी, यू आर गिविंग द मनी. So V is actually, it is V which is giving this change in velocity, change in position. Change in position खुद से नहीं होगा, ठीक? समझ आ गई बात?
Yes.
अच्छा, अब इससे क्वेश्चन तो उठता है ना कि what causes velocity? तो ये गलत हो गया. The error should be this way. Now tell me what causes velocity? Velocity का cause क्या है?
Acceleration cause करती है.
Acceleration. अभी आपको समझ आने लगी है, ठीक है? जब आप गाड़ी स्टार्ट करते हैं उस टाइम पे ना वेलोसिटी होती है ना डिस्प्लेसमेंट होती है, दोनों जीरो होते हैं ना. ये भी जीरो होता है और ये भी. तो आप वहां पे क्या जनरेट करते हैं? Acceleration gives you a change in velocity, and ultimately जब आप किसी जगह पे पहुंच जाते हैं तो displacement खुद ब खुद आ जाती है, ठीक है? Now the next question, what causes acceleration?
Jerk.
बिल्कुल jerk. Actually you need some kind of interaction, yeah, some kind of, और forces की discussion इसलिए आती है, ठीक है? So you introduce force as the cause of a change in velocity, ठीक है? So इसका मतलब ये हुआ कि, और अभी थोड़ी देर पहले मैंने आपको ये भी बताया था कि why was velocity important, क्योंकि we could not actually calculate distances without that. So now we need to discuss acceleration as well, okay? Acceleration के लिए I will follow the same procedure, yeah? It's the derivative of velocity. And now I start again with that two cases, yeah? So maybe I just show that derivation on another page. Although these derivations are not very accurate because I am separating linear motion from circular motion, and when they are combined things get more complicated, but we assume that we are only discussing one of them. So let's say I want to start with v of t, and that is the magnitude times the unit vector, and now I differentiate this with respect to t, and I differentiate this with respect to t, and this is what I will mean by acceleration. So now let's break this down into two parts, okay? पहले मैं क्या करूँगा? I'll differentiate v, so it will be dv over dt, and this is speed, remember. And I will not differentiate this, plus this time I will not differentiate the speed, and I'll differentiate the unit vector of velocity with respect to time. This is that tangential velocity, okay? So वही decomposition, ये कौन सी acceleration है बताएं? Linear, क्योंकि इसमें velocity का direction change नहीं होता, ठीक है? And this is the magnitude of that acceleration in a straight line, ठीक है? कि only the magnitude is changing. It can be positive, it can be negative, but it cannot be in a different direction. और ये क्या होगा?
Circular.
ये circular, ठीक है ना? ये circular है, ठीक है? अब ये circular acceleration किस direction में होगी? We need to know. हमें ये तो पता था ना कि when we were in a circle, so from circle, from center, any point was like that. This was the direction of the ER, and then when we were moving this 90-degree angle, this was the direction of EV basically, yeah? EV was perpendicular to ER. याद आ रहा है ना ये? अब question ये है कि ये क्या है? So we start again with dEV over dt, ठीक है? So again, we cannot say whether this will be a unit vector or not, क्योंकि time का नहीं पता हमें ना. So the first thing we can do is that we apply the chain rule, yeah? और चूंकि हमें पता है distance का, तो पहले हम distance try कर लेते हैं, ठीक है? Can you tell me what will this be?
Speed.
ये speed हो गया. And I can write this now, dEV over ds. Can I say anything about this vector, whether this derivative would be a unit vector or not? Remember, let's say I am in a circle, yeah? So here I have this as my EV at time t. Let's say after some time, this will be my EV, t plus delta t. So the difference between these two, yeah, will be in a triangle, yeah? This is EV of t, this is EV of t plus delta t, and this will be delta EV. अब यहाँ पे देखो कि ये क्या है, ये जो ट्रायंगल मैंने बनाया है इसमें ये दोनों साइड्स का लेंथ क्या है, बताएं. Let me show you that triangle in the slides as well. Can you see this triangle? This one? This one? This is EV. This is EV. So if this was not theta, if this was time, you would have the same problem, yeah? That you have a unit circle, you have a circle within a circle, okay? क्योंकि दोनों से आप फिर एक circle बना लेते हैं. But ds, the denominator ds, yeah? ये तो आपको समझ आ गई ना? ये मूव क्यों नहीं हो रहा? Okay. Okay, maybe this was the last page. Okay. So this DEV is the change along a circle, but this a unit circle, sorry, a change along a unit circle. Yeah. But this DS is change along the actual circle. अब एक unit circle है, दूसरा नहीं है, तो this will also not give us a unit vector. Unit vector हमें नहीं दे सकता, ठीक है? This cannot give me a unit vector. Let me make it clean now. So this will not give me, although this is V times DEV over DS, but DS and DEV, they are on different circles. So let me now do another trick. Instead of DS, let me apply the chain rule again, d theta and d theta over ds. ये मैं कर सकता हूँ, ठीक है? Now d theta over ds is 1 over d theta, ds over d theta, and I know that is 1 over r, okay? So this will give me r, and this, no, this will not give me r, this will give me 1 over r, okay? 1 over r. And this, if you think, now both are again on the unit circle. EV is on the unit circle, delta EV is on the unit circle. We already know delta theta is also on the unit circle, so this will be a unit vector. Unit vector. ये बात समझ आ गई? या नहीं? जो ट्रिक हमने पहले यूज किया वही ट्रिक हमने दोबारा यूज किया, ऑल्दो इसके लिए हमें चेन रूल 2 दफा अप्लाई करना पड़ा, पहले सिर्फ एक दफा कर रहा था, ठीक है? Now यहाँ पे let me now get back to that slide because I have already summarized that, and we now have for the circular motion the normal component of the acceleration. This was already done, is v squared times this derivative, and then we had to apply the chain rule again, and we have v squared over r. You already know this expression, and this thing we know is a unit vector, but we need to ask what is the direction of this vector? इस वेक्टर का डायरेक्शन क्या है? तो उसका आसान हल ये है कि I told you what happens when you differentiate a unit vector with respect to theta. You have a unit vector, yeah, unit vector, and you differentiate with respect to theta. What did you see last time? 90-degree rotation, yeah. So remember, you started with ER, you differentiated it, so you rotated it by 90-degree and you got EV. If you differentiate again, you will get another 90-degree rotation and you will go back to the center, and that's why this derivative is actually minus ER. It's from the circle to the center, okay? So that was the advantage of using this vector differentiation, because now you know that d, whenever you apply d over d theta to a vector, and if that vector you know is a constant vector, then this will simply give you a rotation of 90 degrees, okay? Now we have too many expressions and it will not be easy. By the way, can you recall this expression? If v squared over r आपने कहाँ पे देखा है? I'm sure you can recall this. This is centripetal acceleration. Centripetal, हाँ?
जी जी जी
Centripetal, ठीक है ना? उसमें mv square over r होता है, लेकिन वो force है यहाँ पे velocity, यहाँ पे acceleration है, ठीक है? Actually, it's the magnitude of centripetal acceleration, क्योंकि v squared is the square of the magnitude, okay? Velocity का square नहीं होता, ठीक है? क्यों नहीं होता velocity का square? If v is velocity, I cannot have a square of it. Why? This is wrong. किसी को याद आ रहा है ये क्यों गलत है?
फिर बता दें एक बार क्यों नहीं ले सकते स्क्वायर?
हाँ ना, वेक्टर का स्क्वायर क्यों नहीं ले सकते हम? ये स्क्वायर जो हमने किया है ये वेक्टर का स्क्वायर नहीं है, ये मैग्नीट्यूड का स्क्वायर है, स्केलर का स्क्वायर है, ठीक है? वेक्टर का स्क्वायर डिफाइंड ही नहीं है, ठीक है? वेक्टर्स के बारे में आप क्या कर सकते हैं? डॉट प्रोडक्ट कर सकते हैं आप और क्रॉस कर सकते हैं, ठीक है? These are the only two products and there is no such thing as one vector multiplied by another vector. ये इस तरह का कोई नहीं होता, ठीक है? अच्छा, आ रही है आवाज? क्योंकि लाइट मेरे ख्याल में दोबारा फ्लिक कर गई है, तो ये डिस्कनेक्ट तो नहीं हुए हम ना?
Yes, sir.
Okay. So we have too many different formulas and it may not be easy, क्योंकि यहाँ पे बहुत सारी चीजें, यहाँ पे देखो ना, ये मैंने जो अलग अलग केसेस बताए हैं, ये लिनियर मोशन और सर्कुलर मोशन अलग अलग तो ठीक है, लेकिन जब आप इसको कंबाइन करेंगे तो ये फॉर्मूलाज इतने सिंपल नहीं होते. सो an easy way of remembering these formulas is to have the vector notation, okay? So you have linear and angular velocity. So this is the general definition which you remember. And the angular velocity, so far we only know that as theta dot, but that is angular speed, okay? So angular velocity is definitely angular speed times, अगर इसको आप मैं otherwise लिख लूँ तो I have omega as a vector and theta dot is the magnitude, and I just need a unit vector in the direction of omega. But where will that be? That, because it's a consequence of position and tangential velocity, so it turns out that these two must be cross multiplied. Okay, so when you cross multiply R and V, the magnitude changes. So we know this is the correct magnitude. So it is better to just to take the cross product of unit vectors so that the magnitude is not actually changed. Okay, so this will give me the correct unit vector. Okay, समझ आ गई बात? And you can think about it. देखो ना, ये R और ये V और अब इसका क्रॉस वो राइट हैंड रूल लगा दें, so it will be out of the page, and that is what you mean by angular velocity. ठीक है, that is the correct direction. And if you want, you can also this is basically tangential velocity with theta. So v theta can also be recovered from this product omega cross r. Omega is out of the page and you cross that with r and you should get v theta. So it's better to remember these formulas because they are very neat compared to the complicated formulas before. Okay. Now we need linear momentum. Yeah, is mass times velocity. Why do we need linear momentum? Why is velocity not enough? Or in other words, if I want to characterize motion or the quantity of motion, the quantity of motion is given by momentum, not by velocity. क्यों? क्योंकि वेलोसिटी की डेफिनेशन के लिए मास का होना जरूरी नहीं है. क्यों? You can have an abstract point in geometry. इस पॉइंट का कोई मास नहीं है, कोई चार्ज नहीं है, nothing. This is just a point of geometry, and you can imagine it moving, और उसकी you can still define velocity. क्योंकि velocity की definition में कहीं पे मास आ रहा है, बताएं? Is it required to have mass in order to define velocity? मास हम अपनी तरफ से लगा लेते हैं ना, क्योंकि आसान होता है सोचना. ठीक है? You can also have a charge in motion, or charge in motion में you ignore its mass. Okay, so you can have anything in motion, and photon को तो mass भी zero होता है, ठीक है? लेकिन photon की भी velocity होती है. So momentum में mass और velocity दोनों का multiply करेंगे, so you will have something which represents motion. ये बात समझ आ गई आपको? Now linear and angular acceleration. Linear acceleration, we already covered it. Yeah, v dot, and in the same spirit you can put this dot on the angular velocity, and you will get angular acceleration. Okay. And interestingly, those complicated formulas from the previous page can be simplified like this. Tangential velocity along a circle, yeah, is simply the derivative of the tangential velocity. Tangential acceleration is the derivative of the tangential velocity, and you can express this as a cross product. जिस तरह ये क्रॉस प्रोडक्ट आप लिख सकते हैं, वैसे ये तो हम खुद भी कर सकते हैं. आप इसी फॉर्मूले पे अप्लाई करें d over dt, yeah, because it's a motion along a circle, so this will become v theta dot. R is not supposed to change because you are in a circle. Yeah, R can only rotate. Or omega dot will give you alpha. Omega dot gives you alpha. So this alpha cross R is a consequence of omega cross R because you differentiated it. And you can also recover the normal वो जो v square by R हम लिख रहे थे ना स्पीड के लिए, सॉरी स्पीड नहीं, मैग्नीट्यूड ऑफ एंगल सेंट्रीपिटल एक्सेलरेशन, तो उसके लिए हम ये जो है ना वेक्टर फॉर्म में भी लिख सकते हैं, ओमेगा क्रॉस v थीटा. And if you want to just double take the magnitude, you can just take the magnitude. Magnitude is the magnitude of omega, magnitude of theta. I know magnitude of omega is V over R, and this is V. So V square over R, you get that V squared over R back, okay? So these formulas are easy to remember, and because they are in vector form, so if you use them in problem solving, chances are very less that you will make any serious mistake. The next thing we need to cover is Newton's laws. Okay, you already have studied Newton's 3 laws many times. I only need to touch upon the important things which you need to remember in this course. So the first law, actually, कोई स्टेटमेंट आप रिपीट कर सकते हैं? फर्स्ट लॉ की स्टेटमेंट क्या है? न्यूटन फर्स्ट लॉ कोई भी? उसमें इंपॉर्टेंट चीज क्या नोट करने वाली है? If you think about this, I can say it in many ways, but what it tells you is that if you want to have a change of motion, that is not possible without external force. So external force is required if you want to have a change in motion. So that's what it does. It identifies what is it that causes a change in motion. ठीक है ना? So what you see that, okay, change in motion, and by motion we mean change in momentum, okay, because motion is characterized by momentum. So change in motion requires external force. This is basically the essence of first law of Newton. अब second law explains how it does that. तो अब यहाँ पे क्लियर है कि ये जो चेंज इन मोमेंटम है, दिस विल नीड सम टाइम. इट विल नीड सम टाइम. इट कैन नॉट हैपन विद इन नो टाइम. सो इसका मतलब ये है कि जो आपका फोर्स है, force itself cannot do anything unless you integrate it with respect to time. Or if it is short, you simply say, okay, F times delta t. This is what we mean by impulse. So impulse is the overall action of a force over a period of time. क्योंकि टाइम नहीं हुआ तो फोर्स का कोई फायदा नहीं है अगर टाइम आपके पास जीरो है तो. So force multiplied by time gives you the impulse. That impulse is the cause of change in momentum. This is how you rewrite the Newton's second law. Second law can be written in this form. अब अगर आप डेल्टा टी को इधर ले आते हैं, ठीक है, तो आप डेल्टा mv over delta t, so change rate of change momentum is external force, और F is equal to ma. फिर इसका स्पेशल केस है क्योंकि m कांस्टेंट है. समझ आ रही है बात? Third law just reminds you that all the interactions they must come in pairs. So अब इसका एक consequence ये निकलता है कि let's combine first law and third law. Okay, मेरे पास first law है and third law है. Let's combine these two. And if I have a system which has 2 or 3 objects moving here and there and bumping into one another, but the overall system has no external force, so F external is 0, you also say that this system is closed. Okay, now इस पे what is the consequence of first law and third law? First law का मतलब ये है कि because there is no external force, no change in motion is possible. So change in motion must be 0. अब change in motion यहाँ पे क्या है? Delta of what? बताएं. Delta of what must be 0? Of, okay, that represents motion. Okay, so which means that, okay, if you have m1 v1 m2 v2, these are different bodies with their momenta, and let's say this is the initial momentum, this must equal the same quantity, m1 v1 plus m2 v2, final momentum. So in any time interval, the initial momentum, overall momentum must equal the final momentum. That's the conservation of momentum. So conservation of momentum is a consequence of first law and third law. Okay. Why first law? Because first law ensures that there is no external force, and third law ensures that whatever happens inside the system, that will happen in pairs, and action reaction are equal, so the net will be zero. Okay, it just confirms it. You don't need actually both laws, but they just confirm it. So we can now move on to some examples. And these examples are very simple, so you can try this yourself as well, but we'll just touch upon the strategy. So let's say a body has a mass of 30 grams, mass is given, moving with a speed of 20 meters per second. So you have mass and speed. Now it collides, so you can say, okay, you know m1 and you know v1, the speed. It collides with a second body which has a mass of, so m2 given, and its speed be given. So you know m1 v1 and you know m2 v2, and you know both of them before collision. They are going to collide, yeah, and you know them before collision. Assuming that the bodies have the same velocity after impact. Impact के बाद जो after है ये m1 v1 m2 v2 ऐसे है कि ये दोनों velocity same हो जाती है. So v1 after the impact is equal to v2 after the impact. Determine the common velocity. So you will simply apply this conservation of momentum. Conservation of momentum. Okay. There are two cases. In part A, when the initial velocities have the same line of action, so you assume that they are in the same line of action and the same sense. Same sense means, okay, that if v1 is this is position is directed this way, v2 is also directed this way. ठीक है ना, लेफ्ट राइट अप डाउन जो भी है. सो इसमें इनके साइन अगर इसको आपने पॉजिटिव साइन दे दिया तो इसका भी पॉजिटिव हो जाएगा. पार्ट बी में ये है कि when the initial velocity have the same line of action again but are opposite in sense, so you assume that okay, v2 is this way and v1 is this way, minus sign उसमें आ जाएगा. So you assume motion, for simplicity you can assume x axis, लेकिन अब क्योंकि आपको पता है कि same line of action है, ठीक है, it doesn't matter. This one is even simpler. So you know again a mass of 40 grams with a speed of 15 milliseconds collides with a rigid surface. So you have m1 v1 and they both hit a rigid surface and rebounds. ठीक है, rebounds with a different velocity, so v2 or m1 नहीं, v2 नहीं है, सॉरी, ये v1 initial है and ये v1 final है, and this thing is so rigid that let's say v2i and v2f both, they are both zero because it doesn't move. Okay, so only this object moves. If you apply this change in momentum, okay, this value is given 2, so v1f is also given 0.2 meter per second, v1i is given 15 meter per second. No, sorry, this is 15 meter per second and this is 5 meter per second. Okay, the duration is 0.2 millisecond. So determine the impulse. अब impulse का क्या तरीका है कि impulse is f delta t, but you don't know f, It's just the change in momentum according to second law. So change in momentum is m times delta v. You know m here, 40 gram, and you know delta v. Delta v is the difference between these two velocities. 15 minus, it is 15 plus 5 क्योंकि ये जो है ना ये it will be minus 5, yeah. So 15 minus 5, it will be 20. And the impulsive force at the surface, so once you know the value of F delta T, you just divide this by delta T and you will get F. The last question is for an aircraft which turns at constant altitude. The following arc of the circle. Oh, okay, so because it has a large altitude, so let's say if it is Earth, and you have this altitude, and it is actually giving this arc. So you know R, which is 1.5 kilometer. If the maximum allowable acceleration, which means the magnitude, is 2.5 times g. G is 9.8 meter per second squared. So this is the maximum magnitude of acceleration, okay? Now you want to know the maximum speed. Maximum speed kya hai? Now because it is motion in a circle, so you know the acceleration here is centripetal, okay? Tangential acceleration जो है ना, yeah, centripetal acceleration. So linear acceleration over zero क्योंकि it remains in the circle. So आपको याद होगा वो v square over r. So v max over r is amax, and you just solve this for v max, which is amax times r, and then take the square root. So that was it for today, and we meet on Friday inshallah for the next lecture. कोई question है तो हमारे पास कुछ time बचा हुआ है 2-3 मिनट. Or make sure that you mark present.